Happy Monday morning. Time for 6.1 review. Hope you had a nice weekend. Some nice weather. I did. So let's get going. First problem. Simplify a squared b times ab cubed. First thing to recognize is when you have these parentheses together, that means you're multiplying everything. The first thing I would do is get rid of those parentheses and just rearrange this. This is a squared times b times a times b cubed. Because of the commutative property of multiplication, we can rearrange the multiplication order. So this becomes a squared times a times b times b to the third power. Now, a by itself is the same as a to the first, and b by itself is the same as b to the first. So now we can use the multiplication property of exponents to give us a to the 2 plus 1 times b to the 1 plus 3. That makes a cubed times b to the fourth, or we can just write it a to the third, b to the fourth, just like that. Okay, in the next problem, we're going to multiply and simplify the quantity negative 2xy times the quantity negative 3x to the fifth y. And we'll do this one kind of like the last one. Rewrite this, rearrange, and put the x's together, the numbers together, and the y's together. So see if you can finish this one. Okay, so when we rewrite this, rewrite it as negative 2 times negative 3 times x, and I put 1 as the exponent, x to the first times y, x to the fifth times y to the first times y to the first. So the negative 2 times negative 3 makes positive 6, x to the 1 plus 5, y to the 1 plus 1. So we get 6 times x to the sixth, y to the second, which we can just write 6x to the sixth, y to the second. Okay, for our next problem, we're going to multiply and simplify 3x squared y quantity cubed. Now, a mistake people will sometimes make is to not cube the 3, but what we have here really is 3x squared y times 3x squared y times 3x squared y. And we could work it out that way, which would give us 3 times 3 times 3 times x squared times x squared times x squared times y times y times y. Now if we do it that way, we get 3 times 3 times 3 is 27. X to the 2 plus 2 plus 2 is x to the sixth. Y to the 1 plus 1 plus 1 is y to the third. But there's another way we can do this problem, and that uses another property of exponents. When we take the third power of that quantity, we can just raise each quantity to the third power. So we have 3 to the third, x squared to the third, times y to the third. Now, there's the exponent property, and look in your book or notes and review this. The exponent property, when we raise a power to a power, we multiply exponents. 3 to the third is 27. X squared raised to the third, we don't add exponents, we multiply them. 2 times 3, and then we have our y to the third, and that gives us our answer of 27 x to the sixth, y to the third. So it's a little shorter to use that rule, raising a power to a power. And I did it the first way just to kind of demonstrate why we end up multiplying the 2 times 3. It's because we have 3x squares. So we have to multiply the 3 times the 2 to get the correct exponent on 6. Okay, in the next problem, kind of like the last problem, except we have 2 quantities that are raised to powers, and then we take those 2 results and multiply them together to get a final result. So what you want to do here is do the 2ab cubed to the third equals, do the negative 4ab cubed squared equals, obtain those 2 results, then multiply them together. So see if you can find those 2 results on your own, pause the video, then we'll multiply them together. So the first quantity, 2ab cubed to the third, we take 2 to the third, a to the third, and then b cubed to the third. 2 to the third is 2 times 2 times 2, 8. Then we have a to the third, and then b to the 3 times 3. We multiply exponents. So that's 8a squared b to the 9th. Okay, in the second quantity, negative 4 squared is 16a squared b to the 3 times 2. And that gives us 16a squared b to the 6th. Now we multiply those 2 results together. 8a squared b to the 9th times 16a squared b to the 6th. And that's just like the first problem or second problem we did. So see if you can finish this off and get the final answer. So we just regroup here. 8 times 16 times a squared times a squared times b to the 9th times b to the 6th, and 8 times 16 is 128. It's 80 plus 48. A squared times a squared, it's a to the 2 plus 2. And then b to the 9th times b to the 6th is b to the 9 plus 6. So our final answer is 128, a to the 4th, b to the 15th. And in double checking, I see I changed that 3 to a 2. What the heck is wrong with me? That changes things a little, so sorry about that. So that first a is a cubed. So it's actually, the final answer is 128, a to the 5th, b to the 15th. Okay, the next few problems deal with negative exponents. I know this is in your notes, but I thought I'd just go over it quickly before we get into these. Again, a to the negative power is 1 over a to the positive, or a to the negative n power is 1 over a to the positive n power. And if you have 1 over a to the negative n power, it becomes just a to the positive n. What that means is if you have a negative exponent, a negative power, you end up moving that power to the other side of the fraction bar, if there is a fraction bar. Now for this example here, we could write 1 over a to the negative n as a to the positive n over 1. And likewise, a to the negative n over 1 is 1 over a to the positive n. So my example here, x to the negative 2, we can just move that negative 2 power to the bottom and it becomes positive 2. The y to the negative 3, we move that to the top as y to the positive 3. So that's what you need to remember. Negative exponents means invert and use the other, or the positive power. So here's an example like number 7 of the homework. Write 1 over 4a to the negative 2 with positive exponents. Well, here, the 4 is not raised to the negative 2, only the a is. So invert, use the opposite power. We move the a to the negative 2 into the numerator and write it with a positive power. So our result here is a to the positive power over 4. And that's all you can do. So that's it. Okay, in the next example, I have the quantity 3x to the negative 4, and we want to write that with a positive power. So here, the whole quantity is to the negative 4th, so that means the whole quantity is moved to the denominator and uses a positive 4 power. Now, forget about the fraction, just remember what we did in the previous problems. If we raise 3x to the positive power, that means we're raising 3 to the 4th and x to the 4th. Well, 3 to the 4th is 3 times 3, 9, times 3 is 27, times another 3 is 81. So we have 1 over 81 x to the 4th. The next problem deals with the 0 power. If you have the 0 power of anything, positive or negative, it equals 1. The only exception is 0 to the 0 is not defined. But anything other than 0, even if it's negative, your answer is 1. So a problem like number 9 of the homework, negative 2x y to the 3rd raised to the 0. Well, it's 1. That's it. Anything to the 0 is 1 except 0 itself. So that's all you have to remember when you have a quantity. And it doesn't matter what the quantity is. It could be 3x plus 4y to the 7th, all raised to the 0. It's 1. As long as x and y were not 0 themselves. But anything other than 0 raised to the 0 is 1, negative or positive. Okay, in the next problem, we're going to multiply 3x to the negative 2, y to the negative 2 times negative 2xy to the 4th quantity squared. So this is sort of a combination of a bunch of problems we've done. So your first step here is to square out this quantity. Once you do that, multiply by the first quantity. So see if you can do that, square that out, and then we'll go from there. So when we square out this second quantity, we square the negative 2, we square the x, we square the y to the 4th. Negative 2 times negative 2 is 4, x squared, y to the 4 times 2. We use the product of the exponents when you raise a power to a power. So we have 4x squared y to the 8th. So now we multiply that first quantity times this result. So when we do that, we're going to rearrange this as 3 times 4 times x to the minus 2 times x to the positive 2 times y to the negative 2 times y to the 8th. And you're probably wondering, can I use the exponent rules with negative exponents? And the answer is yes, you can. 3 times 4 makes 12. X to the negative 2 times x squared, adding negative 2 to positive 2 makes x to the 0. Y to the negative 2 times y to the 8th. Negative 2 plus 8 is y to the positive 6. Now x to the 0 turns into 1 because anything to the 0 power is 1. So our answer is 12y to the 6th. The x's are gone because the x to the 0 turned into 1. And if you noticed, if we had written 1 over x squared times the x squared, that would have given us x squared over x squared, which is 1 as well. But I chose to just use the exponent rule here. Okay, the next few problems can use the division rule for exponents. If you have x to the a over x to the b divided by x to the b, the result is x to the a minus b. We subtract exponents when dividing. So we apply it to this problem. Simplify 32x squared over 10x to the 6th. Well, the 32 and 10, they can be simplified the way we normally simplify fractions. 32 divided by 2 is 16. 10 divided by 2 is 5. So the 32 tenths turns into 16 fifths. Now the x's, we can use the division rule and get x to the 2 minus 6. So that's 16x to the negative 4 over 5. But the negative exponent rule says, put that x to the fourth into the denominator. So we get 16 over 5x to the fourth. Now there's another way of doing this without using that division rule, and for a lot of students it's a lot easier. Well, first of all, the 32 tenths we handle the same way. Divide 32 by 2, divide 10 by 2 to get the reduced fraction 16 fifths. Now the x squared and the x to the 6th, what we're really doing here is dividing x squared by x squared to get 1, and when we divide x to the 6th by x squared, we get x to the 4th. Because what we really have is x times x over x times x times x times x. We have 2 x's over 6 x's. 2 x's cancel, leaving 1 over x to the 4th. So doing it this way, we get 16 over 5x to the 4th, canceling factors of x rather than getting using the division rule and dealing with the negative exponent. A lot of students find that a lot easier to do. Okay, in this last review problem for exponents, simplify the fraction 2x cubed y all raised to the third over 4xy cubed all raised to the third. Give the answer with positive exponents. This is sort of like number 12 of the homework. So what you're going to do here is simplify the numerator, simplify the denominator, then divide the results. So see if you can do that on your own. Pause the video and try to simplify both numerator and denominator first, and we'll go from there. So the numerator turns into 2 cubed x cubed quantity cubed y cubed, which turns into 2 times 2 times 2, 8 x to the 3 times 3. When you raise a power to a power, multiply exponents, y to the third. In the bottom, 4 cubed is 64, x cubed, y cubed raised to the third. Again, multiply exponents, 3 times 3. So we get y to the 9th in the denominator. Now we just simplify this. You can either use the exponent division rules or cancel factors. I'll do it both ways. So we simplify the fraction just by canceling. 8 goes into 8 one time. 8 goes into 64 8 times. So we get the 1 over 8. X to the 9 minus 3, using the division rule for exponents, makes x to the 6th. Y to the 3 minus 9 is y to the negative 6. But we move that y to the negative 6 into the denominator as y to the positive 6 power. So, and then using the canceling method, we just take 8 into 8 is 1, 8 into 64 is 8. 3 x's cancel out 3 x's of the 9 x's in the numerator, leaving 6 x's. The 3 y's cancel out 3 y's in the denominator, leaving 6 y's in the denominator. So that gives us the answer x to the 6th over 8y to the 6th. Canceling out factors and then just going that route, which I think you'll find is easier for most of these problems. It's good to know both ways. And here's a quick review of scientific notation. Scientific notation is rewriting a big or a small number, so you have one non-zero decimal to the left of the decimal point. Just remember, you move that decimal point, count the places. Big numbers use a positive power on 10. Small numbers use a negative power on 10. So the first example, we move the decimal point 5 places. So our scientific notation is 5.3 times 10 to the positive 5. In the second example, our small number, we have to move the decimal point 1, 2, 3, 4 places, but it's a small number, so we multiply 1.4 times 10 to the negative 4. And then to rewrite scientific notation in decimal form, we use the same procedure. Positive exponents means big number, negative exponent means small number. So here in these two examples, 2.13 times 10 to the 4th, the positive power on 10 means it's a big number. To rewrite it in non-scientific notation, we move the decimal point 4 places to the right to make it this big number, 21,300. 4.03 times 10 to the negative 5th, the negative power means small number, because that really means we're multiplying by 1 over 10 to the 5th, or we're dividing by 10 to the 5th. We move the decimal point to the left to make it this small number, 5 places. Now here, to move it, we have to add placeholders, 0 placeholders. And in the first example, we had to add 0 placeholders as well. So that's it for this section. Sorry it was a bit long, but there was a lot to do in this section. See ya in 6.2.